Yeah, we're going to be talking today about how to speed up .NET and SQL Server web apps. I'll just give you a little bit of background first. So my name's Bart Read, and I'm an independent consultant nowadays. I used to work for Redgate for about 10 years, and I've touched a lot of their tools over that time. Worked on a lot of the SQL tools like SQL Prompt, the comparison tools, the command lines, and also the profilers, so Anti-Performance Profiler and Anti-Memory Profiler. Nowadays, I spend a lot of time with clients, mostly doing performance tuning work, just because of my background. So what I'm going to talk about today, I'm going to talk about web performance in general terms. So I'm not going to talk to you about client-side performance, for example. I'm not going to talk about things like why it's important that your website is performant. I'm really going to focus on the areas that I found people struggle with. And it's not so much the code on the server side, but the database. So people often struggle with SQL Server. So what I'm going to present to you today are some real-world examples, albeit with the names changed to protect the guilty, to give you an idea of how you can approach fixing a performance problem that involves .NET and SQL Server. And hopefully you'll come away with a few pointers about how to approach the problem. So we'll talk about some of the tools and techniques that I've used. It's not an exhaustive list of all the possible things you can do to make your SQL Server database slow, because that is a very long list. However, if you do have anything you want to ask about, if anything's not clear, please do just stick your hand up and ask questions, and I'm happy to hang around at the end and take questions as well. Or you can just get in touch with me. I'm very happy to hear from you. So if you do care more generally about the sort of front-endy part of web performance, I actually have a blog post that deals with more general web performance, so go and read that. So first off, I just want to talk a bit about tools. So tools really make the difference when you're tracking down performance problems, and they make the difference between finding the performance problem and not finding it. It's that simple. And the problem is that as a developer, for me, tools for dealing with code feel a bit like the image on the left here, whereas tools for dealing with SQL often feel a bit like the image on the right. It feels like there is much richer tooling available. However, that is changing. A lot of vendors are now producing tools that really make it a lot easier, and Redgate's done a particularly great job here of allowing you to delve into what's going on in SQL Server. So anyway, the first thing you're going to need is a performance profiler, and you're probably going to need a memory profiler as well, because I'll talk about in one of the examples, memory issues can really hurt your performance, which you may not realize. So I'm hugely biased. I used to lead the .NET development team at Redgate, so we built Anti-Performance Profiler and Anti-Memory Profiler, the earlier versions, and so I'm hugely biased towards those tools, but I don't really care, just get yourself a profiler. The other two tools that are invaluable, obviously you'll be familiar with Management Studio. You may not be so familiar with SQL Profiler, which is accessible via Management Studio. Again, it's quite an unfriendly tool, but it is a very valuable tool for diagnosing performance problems in SQL Server. It's actually been deprecated. However, Microsoft haven't provided a great interface for using their new mechanism. So if you want to pull out events, trace events from SQL Server using the new mechanism, you have to write a big wall of SQL, and it's not terribly friendly. There are examples of this online. I'm not going to talk about that because it's just easier to use SQL Profiler for now. My suspicion is that Microsoft will be providing a better front end for doing this in future versions of SQL Server. The other thing that comes in handy is some sort of load testing tool. Now, load testing, again, is something that used to be really quite a pain in the backside. Nowadays, it's much easier. Tools like Noistar, tools like BlazeMeter make it much easier. So the one I've used is Noistar, so you write Java code which exercises your website. And because they have data centers all around the world, you can fire traffic at your website from all over the world. This does, of course, presuppose that the machines you're testing on are visible on the public internet, so that's something you need to think about. If If you can't do that, you're back to the more old school load testing tools. SQL Server monitoring tools. So this one on the left is obviously Redgate's SQL Monitor. That's a great tool, very competitive on price, does everything you basically need. There is no great solution. So the one on the top right is SolarWinds, then the one in the middle is Spotlight on SQL Server. That's a desktop app, sort of rocky, like it's 1995. And then there's, of course, New Relic, which many people have heard of. New Relic's great for kind of giving you an overview of your whole solution. What it doesn't do well is SQL Server monitoring. It's very, very basic. I've just started naming Redgate about making this to this, which it doesn't do at the moment. So what I'd say is with all these monitoring tools, if you're in a situation where you've got, say, a dozen SQL Server instances with several hundred databases on each instance, none of these tools scales that well. They will work, and they won't bring, there's no performance issue. What I mean is, where they don't scale is in presenting the data to you in aggregate form. It's quite hard to see. So for example, if you're getting deadlocks, you might want to know which databases you're getting the most deadlocks in. That's quite hard to dig out. Redgate's actually provided some reporting for that, which makes it a bit easier. That's something you have to do through SSRS, then, I believe. And then there are some ancillary tools. So Dependency Tracker is a great way of visualizing a database. It's really handy until you come to a client that doesn't have any foreign keys because they don't believe in them for whatever reason. There's obviously things like Proc Monitor, SQL Prompt, really handy for IntelliSense. I don't use Procmon that much because there are other tools that are richer. Fiddler can also come in useful, obviously, or likewise Chrome Dev tools. Okay, so let's talk about our first scenario. Pretty typical end-tier application here. So you've got your ASP.NET MVC front end, you're using NHibernate to interface with a database in SQL Server. The only really interesting thing here is that there's this Microsoft Dynamics database sitting in the background on a linked server. Now what this is a customer support center for a client of mine. And they're basically a business-to-business e-commerce provider. And their customer support team is responsible for dealing with things like invoice queries, credit card payments that fail to go through, these kinds of things. So people phone them up with support issues effectively. So one of the issues with their new support center, which they just shipped earlier this year, was that many of the pages would take quite a long time to load. By quite a long time to load, I mean anywhere between 15 and 40 seconds, which for a web page, even on an internal app, which you don't necessarily expect to be as slick and fast as your public-facing site, is not great. And the reason it's not great is because you've got to keep that customer talking on the phone for that time. So it's increasing your support costs, it's annoying the customers because they're waiting in a queue for longer to talk to an advisor, or you've just got to hire more advisors. So I sat down with their head of support, who was one of the people who was guinea pigging this new system. And we literally went through every page on the site, and I wrote down all the transitions that were very slow, all the navigation events that were very slow. And then I went away and I basically isolated their production server, attached a profiler, and I went through and I collected loads of performance data. Now I blacked out some things to make it, to hide their identity, obviously. This is what our performance profiler looks like. It does look better on a high resolution screen. This screen is not very high res, so I apologize for that. But the basic interface is pretty simple. You've got a timeline at the top, and that records things like CPU usage, performance counters, etc. And then down below that, you have this view, which in this case is showing you call stacks. So .NET framework call stacks, so that's code. But what it also shows you, I don't know if you can see, there's a little green icon there, which is not very clear. That's showing HTTP request. It will also show SQL, file IO, show you where that's happening in the code. So that age-old problem of this SQL query is slow, but what the hell is running it is much easier to solve here. So, and what I did is I basically use live bookmarks. So I'd start a live bookmark, do the page navigation or whatever action I needed to take for the slow page. Then I'd stop the live bookmark, I'd edit the name, and I ended up with a list of these bookmarks of all the navigations between the slow pages. Dead simple. I mean, here's an example of what I found. So you can see right at the bottom here, there's a couple of SQL queries at the bottom of this stack trace that are taking about, you won't be able to read this, I suspect, but about 10 seconds between them. So it's easy to straight away see these SQL queries are slow, this is where they're being called from in the code. Now, nhibernate makes this ever so slightly more tricky because obviously it's a layer between your code and the SQL. But we'll come on to that in a minute. So you've also got the database call view, which just purely shows you the SQL. Now, this is probably the worst page transition there. That SQL query at the top takes 35 seconds to run. We'll talk about why that's happening in a minute. And then you've got another one that's 5 seconds below. So the overall page load time for that page was something like 40 seconds, maybe a little bit more. So really not great. So one of the things at the moment, so Ant's Profiler will show you the full query, but just because of the way nhibernate generates SQL, it comes out as one big long line of SQL, which I find really hard to read. So the first thing I do is copy and paste it into Management Studio and use SQL prompts to format it. And that gives me something like this. And that looks really innocuous. It's just, it's horrible. That's what nhibernate generates, but it's not complicated SQL, right? So you basically got to select a bunch of columns from this invoice items view, which is, as I say, a view where the invoice number matches that parameter. Now, I don't know what that parameter is, and it'd be helpful. If I'm going to debug this, I need a real invoice number where there's a problem here. So I've got to get that, basically. So next I'm going to show you how I did that. But again, this will become much simpler soon, and I'll explain why in a minute. So to do that, I fire up SQL Server Profiler, which is massively not my favorite tool in the world, but it does do the job fairly well. So there's a bunch of setup stuff here that you're probably not going to want to mess with that much, to be honest with you. But depending on the problem that you're trying to solve, you will want to change the event. So here, really, I'm interested in things like SQL batch starting and batch completing, because I want to know, I want to be able to see where my query is so that I can grab that parameter. There's a whole bunch of stuff around locking in there, which is very useful if you're dealing with locking and blocking problems, which I'll talk about more in a minute. So when you run Profiler, you get a bunch of events scrolling up through the grid. And this does actually slow your server down, so you don't want to do this for too long. You want to do it for long enough to collect the data and be done with it. And basically, in this situation, I just wanted to find the query, so I just used the name of the object and just did the standard control F to find the relevant event. What you can do, and again, only do this if you really need to because it's incredibly slow, but you can actually export this data to a table in SQL Server, so then you can query it like any other data. That's hugely useful for debugging certain problems. So I was tracking down some locking issues. That was invaluable for that. Trying to do stuff in here was an absolute nightmare. The one downside with it is, as I say, the moment you do the export to trace table, just go and get lunch, basically, because you're not going to see that come back for about half an hour, depending on how much data you've collected. But what you can see here, I've got exec, sp, execute SQL. Then I've got my SQL statement there. And then I've got at p0 equals, and I blank out the value, but that's the invoice number there. So now I can go and look at the execution plan. Now, again, I can't really show you the real execution plan here, unfortunately. Oh yeah, this is just me talking about the trace table thing, so I've talked about that already. And you can obviously export to a table in SQL Server. Right, so I need my execution plan. I need to see what's going on here. So I'm going to go into Management Studio, select Include Actual Execution Plan, and then I'm going to fire off my query. Now, an execution plan looks like this. This, as I say, is for a very simple query. That query I just showed you had about, I don't know, 4 dozen different nodes in the execution plan. It was humongous. You keep 4 monitors together would not have been big enough to view it. And right down in the bottom right-hand corner was one box that said remote query 99%. So that's why it was taking so long. Okay, so let's dig into this a little further. So as I said, that query was a query against the view. This is the view definition here. Now, a bit manky, but it's okay. It's not outrageous. It's just a CTE. The key point being this here at the bottom. I've changed the name again, but that's a synonym for a table on the linked server. So what's happening there is when I execute the query, it's pulling back 600,000 rows of data from the remote server, and then doing the rest of the query locally, right? So that's hugely inefficient. You want to write your queries so that your intermediate result sets in SQL Server are as small as possible. You want your queries to be as selective as possible, as quickly as possible. This is one of the reasons I'm not necessarily a massive fan of views, because they are quite non-selective, and they're a great abstraction, but because they're an abstraction, they can hide an awful lot of complexity, and in this case, remote query. So the fix for this, well, one of the fixes for this, we discussed several options actually, but I'll show you this one first. So one of the fixes for this is turn it into a table value function. So the table value function takes an invoice number as a parameter, and we match on the invoice number in the where clause on the remote query. So that match happens on the remote server, on the linked server. And what that means is that we actually pull back about 10 rows of data. So you go from a query that takes 35 seconds to execute, and it takes 0.5 seconds to execute. So that's much better. By the way, I don't know whether I don't think I made this clear at the beginning. I haven't deliberately chosen loads of terrible examples from awful companies here. These are normal people, normal companies with normal products. This is just all, completely routine. The other thing we actually discussed, and what they decided to implement in the end, is replication. So what they've done is they've replicated the tables they need from that Dynamics database into their main website database. And that means that all these queries are executing locally. And now the query optimizer can actually do something sensible with this. So yeah, it's not a great query, but it kind of, it does the job. So I mentioned earlier that all of this was going to be a lot simpler, so I had to go through a bunch of hoops that I had to jump through to get the invoice number. It's going to become a lot simpler in the next version of Ants Profiler. So that execution plan that I had to build up in Management Studio, I can now see directly in Ants Performance Profiler. And they tell me I will also be able to see the parameters that were set for each execution of the query. I'm not sure how they're going to make that interface scale. So same client, actually. I'm just back with them at the moment. They have a problem on their public-facing website, and it's not due to one horrific query that takes ages to execute. It's actually due to, their customer account area. Sorry, is that a question? So it's actually due to pages in their customer account area executing 2,500 queries or more to populate one web page. So again, that's an n-8. Well, it's not an n-8 issue. It's an issue you can run into if you use an ORM like n-8. You need to be really careful about the SQL you're executing. So, and you can customize that, and you shouldn't be afraid to create entities that more closely map what you're showing to the user, rather than trying to reuse something that is a very close analog of your data model in the database. Anyway. So that whole process I went through should become a lot simpler when Ants Performance Profiler 9 is finally released. Okay, so this is a much more .NET-y example. So I won't talk about this one for too long. Same customer, front-end website this time. What we noticed when we were load testing it, so I was purely looking at performance issues at this point, but when I load tested it, I noticed progressive slowdown in the server's response time. So that time to first byte between you send the request and you get anything back from the server at all went from 200 milliseconds up to 4, 5, 6, 7 seconds and beyond. This was a little bit strange, and you know, I said we should probably look into this. So anyway, it's exactly the same architecture. The only thing is they've just injected a couple of other technologies, so N-Service Bus and Endeca, and they're using CQRS and blah blah blah. Yeah, same architecture, same two databases behind it all. Only this time I'm using the memory profiler. Now the memory profiler has a similar interface, but it is subtly different. So whereas the performance profiler just continuously collects data, the memory profiler you have to take snapshots. And the reasons for that is that data in memory is just orders of magnitude more of it than there is about the performance of your application. You know, your average app is creating zillions of objects all the time. How many of you know how the .NET garbage collector works? Okay, I always get this response right. This is the third time I've done this talk, and I really do need to put in a slide about this. So .NET's memory management is really built on two assumptions. The first assumption is that most objects are very short-lived, you know, you basically use them and throw them away immediately. The second assumption is that if objects aren't short-lived, then they hang around pretty much forever. They're very long-lived. So, as a result of that, those two assumptions, .NET uses a thing called generational garbage collection. So when objects are newly created, they start off in generation 0, and when the garbage collector runs, it mostly only collects generation 0. Now, as the object ages, it moves through generations 1 and ends up in generation 2, right? So if you've got a lot of objects that sort of last, you know, long enough to get into generation 2, and then you don't, and then you let go of them, you don't use them anymore, what happens is that you get a lot of garbage building up in generation 2, and then when the garbage collector finally does a full collection where it collects all 3 generations, that collection takes ages, right? And even with server-side garbage collection and concurrent collection, there is some impact on your application. That's a really simplified explanation of how garbage collection works. So the problem, as you can find, is that if you've got a lot of objects being promoted into generation 2, and particularly if you're leaking them and never letting go of them, you hold on to those objects. The garbage collector still has to walk that entire object graph in generation 2 to figure out what's garbage and what's not. So hugely expensive potentially. So what I did here is I used Noistar to set up a load test, and I basically just ramped up to 100 users and held it there for about half an hour and then ramped down again. Their website is such that they've got 4 servers behind an F5 load balancer. So what I was able to do was just pull one of those servers out of the cluster and test only against that, which makes life a lot easier, obviously. So I was taking snapshots all the way along. So that snapshot at the beginning is just after the app started up, before I start the load test. And now I'm taking snapshots progressively all the way along. And when it's finished, I took 3 or 4 snapshots just to be absolutely sure that all garbage had been collected. Really, it's not necessary. Anyone would have been fine. And the thing you're looking for here really is what I'm comparing the first snapshot with the last snapshot. Now, ideally, well, in theory, the app should be in an identical state at that point. Nobody's using it in either case. There shouldn't be any resources hanging around that were used to serve these sessions in between. So, what we're looking at here is basically, well, the question we need to ask is, what objects exist now that did not exist in the first snapshot? So what I'm looking at is newly created objects, and the profiler has these options for filtering out objects that you don't want to see. So here I've said I'm only interested in new objects, and I've also said only show me objects that have source code. And the reason I've done that is because inevitably in every .NET app, right at the top of the list, you're always going to find something like string or byte array because, well, all apps use strings, right? Having found, well, the top result here is this thing called item controller, and that's an ASP.NET MVC controller. And what I found is that regardless of what page I was going to, we were leaking MVC controllers everywhere. And you can see there are loads of them. I think there are about 12,000 instances live in this case. Well, the lifetime of a controller is the lifetime of a request, so something is very, very wrong here. So we actually go and have a look at that class and look at the instance list. And they're all about the same size, so I just really picked one. And what I did is create a thing called an object retention graph. And what I'm interested in is what are the references that go back to the garbage collection routes. So the GC routes, garbage collection routes, are where the garbage collectors start walking the object graph. So how is this object connected to them? And then if you break those connections, then the object's free and the garbage collector can collect it. That's the basic theory anyway. You can't see this at all, this projector is terrible. These slides are available online or will be very shortly, so do please feel free to download them. But basically, there's my linked object right there down at the bottom, and the GC routes are these sort of purpley nodes right at the top of each path. And you can't see it here, but in the midst of all this is a thing called Castle Windsor, which some of you may be familiar with. It's an IOC container, a bit like the inject or autofac. It transpires that, this won't be coming across any more clearly on that either. So it transpires that they have a problem with their lifestyle management code. So Windsor basically allows them to specify certain lifestyles for an object, and what they've done is basically told Windsor to track disposable objects, even though you don't really need to do that for ASP on the MVC controllers, because the MVC itself will manage the lifecycle for you. But so Windsor is doing the object tracking for them. At the end of the request, it should let the objects go, but it's not doing it. Their code's quite convoluted, so we tried various things. Their own registration code was actually, there are 2 instances of it, and it was being executed, and it just wasn't working at all. So I said to them, well, there is this one line of code you can write, but you must clean this up later. So they were desperate to ship. So basically, this tells Windsor not to track the objects, right? So the problem with that is it's now not tracking any of the objects, including any of the ones that they might want to track. Now, as it transpires, they really weren't using any of Windsor's features in that area anyway. So what we've done is create some technical debt for the future. In this instance, I thought that was okay because actually they were about to, well, their plan was to ship and then embark on some refactoring work. They had a lot of contractors in to build this site, and it just needed quite a bit of cleanup. So we did that, and the memory leak disappeared. So that memory graph that was climbing and climbing and climbing just flatlined at that point. So that's the second scenario. The third scenario, we're back in SQL Server now. So I got a call from a client who was saying they were having a lot of problems with deadlocking. Now these guys, they're a bit more interesting in terms of architecture. So they've been around quite a long time now, since the early 90s. And they have a bunch of applications. They're very, very conscious about data security, and they're quite secretive. It's not GCHQ or anything like that, but they're just a company. But they have a legacy of applications dating back to the early 1990s. And so what they have is a database per customer. So obviously they want to keep their data all separate. And actually this turns out to be a really good thing in their case. If this was one database to rule them all, this would have been an absolute nightmare, and all their customers would be affected by it. As it is, it's only a small proportion of their customers who are being affected by the issue. Of course, it is the highest value customers, inevitably. So they have a database per customer, and every app that they've built on top of that accesses the databases by a C++ ADO layer. So that's even the ASP.NET MVC. They've got an iOS app that goes through that layer, and then they have some legacy Win32 apps as well. And so the problem really started manifesting itself as they were getting complaints about data loss from customers. They had no idea what was going on. they installed SQL Monitor from Redgate, and it started sending emails like this, lots of them. And what this is basically saying is that you've got a deadlock. It's telling you which database the deadlock is in, which object it's on, the lock is occurring, the deadlock is occurring on, and the SQL from the two processes is also telling you which one SQL Server chose as the victim. So in SQL Server, when you get a deadlock, it's not like .NET, where it just sort of hangs your application and that's game over, or at least hangs those two threads and that's game over. SQL Server will detect that deadlock and it will choose a victim process and it will kill that process. And the way it makes that decision is by working out which one of them is the cheapest transaction to roll back. It will figure out what it can do that's the least amount of work to clean up the mess, basically. So most people, well, not most people, a lot of people never encountered these issues because in a lot of apps, like in the previous app that we were talking about, it's an e-commerce site. You know, you've got customers, products, invoices, baskets, blah, blah, blah. When somebody comes to the site, they're only accessing their own rows, except when they're looking at products, and all the accesses on products are reads pretty much. They update products fairly rarely. So most people have object-level concurrency, right? And that's why you can get away with running a read committed transaction isolation, right? We'll talk more about that in a minute. Whereas these guys have row-level concurrency. So typically, one or two people will be updating some data at the same time as 12 other people are looking at the same data on their iPads, and maybe some of them are doing updates as well. So you've got this quite complicated situation where people are concurrently trying to update the same data. So I mentioned transaction isolation levels. So people talk about ACID, and they talk about relational databases, and they talk about consistency, and they talk about it like it's magic. It's not magic, right? SQL Server, out of the box, in its default configuration, does not guarantee that if you start willy-nilly updating and reading data, even in the context of a transaction, that everything will be consistent because of your transaction isolation level. If you need that guarantee, you need to run serializable, right? Because at the moment it's possible for you to read a row of data at the beginning of a transaction and then for somebody to modify it and for you to then commit that modification and for you to read it again later in the transaction and get a different value. Might not be a problem, probably isn't for most apps, but ACID, the I in ACID, it's a little bit fuzzy. So yeah, isolation, sorry. Going back to SQL Server Profiler, this is where those locking properties came in. So I really wasn't sure what to expect here, so I just checked everything, which means you get loads of data that you probably don't need, but I'd rather that given the amount of hassle it is to run the profiler. And what I should say at this point, because these guys are so conscious about data security, I'm sat in a room with two guys watching me on an isolated laptop. I can't use any of my own equipment. And I'm writing stuff down in pen and paper, because that's the only way I'm allowed to access their production data. And they can't reproduce this in development, so that's what we've got to do. So SQL Server Profiler will show you deadlocks, and it gives you this deadlock graph, which actually is a hell of a lot more useful than what SQL Monitor will show you. That wasn't really what I was interested in. What I was interested in is what objects are being locked and what order are they being locked in. So these guys have quite an undisciplined way of accessing objects, both in terms of reading and writing. So they'll access objects re-entrantly in different orders. And so that's the classic situation where, you know, if you're writing A, B, C, D, E, A, B, C, D, but you've got a different process doing that, doing a different write in a different order of object access, that's the classic situation in which you're going to get a deadlock. So I actually wanted to understand what processes were causing these problems. And so this is why I sat down with a pen and paper looking at the order of lock acquisition. So three solutions here. So I mentioned the victim process earlier on. SQL Server will always pick a victim and kill that process. But you don't know which one it's going to be unless you set the deadlock priority. So you can, at the very least, make your deadlock victims deterministic. So in this case, what we decided to do was make reads against the database. So somebody is syncing their device or whatever, we decided to make those low deadlock priority, which means that SQL Server would always choose them as the deadlock victim. So by default, everything's a deadlock priority normal. So you don't know what's going to be killed. But we set those to low. So that means the reads are going to be the victim. We can retry those. There's no difficulty there. So there's a retry mechanism in there now. Now that sort of helped, but as I said, they're quite undisciplined about that order of object access, and there is a lot of re-entrant access going on. So they'll access table A and then follow records through tables B and C, and then they'll reference records back in table A again, and so the cycle continues. So there's a lot of lock contention, even without deadlocking. So performance is definitely an issue. And we were still finding the processes were blocking for a very long time, potentially. And then if you run a retry onto the top of that, you're really talking about a very long time. So there is an isolation mode, and this is a database level setting, not a connection level setting. So most of the transaction isolation modes are connection level settings. So you can, in isolation, do your dirty reads or whatever. But RCSI is a database level. And what it means is that SQL Server starts tracking versions of rows in temp.db, and that means there's no logging. So if you look at a row, that version of that row that you see will be tracked in temp.db, and if you query that row again, you're going to get the same value back. Okay? In the meantime, somebody can modify it, and that will create a new row version in temp.db, and so on and so forth. So you can get quite long chains of row versions potentially, and temp.db can grow quite a lot. And if you haven't configured temp.db well, so for example, if you've got it on very slow disks, or you've only got one data file or whatever, you can start to see some performance problems from doing that. But generally, because there's no locking, what you should find is that your app runs a lot faster. There are some issues with this, obviously. So you can get issues with skewed reads and writes. Now, are these issues any more dangerous, any more difficult to deal with than what these guys already had to deal with? So they were looking at, they were in the recommitted transaction isolation mode, and they do not deal well with situations where people can currently modify already. So does this make any difference to them? No. They need to implement a mechanism by which concurrent modifications can be resolved. So they need a conflict resolution mechanism, a bit like a version control system has. So that's another chunk of work they need to do. But this actually removes the deadlocking, and it generally improves performance overall. The other thing that they're going to do, and this is a much longer term piece of work, this is a big re-architecture for them. So they've got, if you look at their databases, they look like SQL Server 7 databases. And again, they've got no foreign keys. I don't know what the no foreign keys thing is, but they don't have them. The naming convention is very SQL Server 7. Everything's got really terse names. Everything's all capitals. It just feels quite old, and it's because they've got 20 years up to of legacy code that these apps are built on top of. So they've got a huge amount of work to move from the sort of ad hoc model they've got now, which is starting to creep around the edges, to a disciplined order of object access. Now, I am not a design patterns junkie at all, but I do think they're a great shorthand nomenclature for describing a solution to a problem. So what I've suggested to them is an implementation of the unit of work pattern, which you'll find in Martin Fowler's book and on his website. So effectively, what unit of work allows you to do is say, here's a list of changes I want to make. and you then say to the unit of work, now go do them, commit, effectively. And what that does at that point is it figures out exactly what order everything needs to be done in. And so that allows you to implement a more disciplined order of object access. So these guys have, the issue for these guys is that their transactions are complicated and long-running. So there's a lot of looking things up, there's a lot of modifying rows in various tables, here, there, and everywhere. So they're quite complex. And as I say, they have this re-entry behavior. So the problem with the unit of work, of course, is that it's actually quite complicated to implement, which is why it's the sort of bottom of the solution file. They are probably going to have to do this, but I mean, I think they're going to need to do it to deal with the issues of conflict resolution as well. It will make that a bit easier for them. But yeah. So a few other scenarios I've come across. You read about these things in books and think, nobody would ever do that. Missing indexes. If you write a query against a table which has a lot of data in it and you include a column in the where clause that doesn't have an index, well, it might be a bit slow. Not always. By the way, you don't always need an index, right? If the last column you're querying against at that point is against an intermediate data set with like 10 rows in it, you don't need to add an index necessarily. So don't go mad on indexes. Maintenance as well. So if you don't maintain your indexes, they will slow down. So SSDs, if you're using SSDs for storage, this gets a little bit better. In that the order of pages doesn't matter so much, but nonetheless, the unit of data transfer for SQL Server is the page. So it transfers a whole page at a time from disk to memory or from memory to disk, right? So if your indexes are fragmented, they're going to be taking up more pages than they should do. And that means that you're going to have to access more pages to, when you use the index, there's going to be a lot more swapping of data in and out of memory. It will slow things down a bit. If you're running on spindles, the order of pages on disk can become important. But again, with SANS, you may not have that much control over that, so that's less of an issue. But do your index maintenance. Statistics, likewise, that's a whole other area. I think Grant will probably touch on those. And what you can find, so I'll mention the store procedure thing now. If you've got a store procedure that most of the time runs in a second, but every now and again runs in 20 seconds, if you supply certain parameters to it, that can be due to statistics because it's been compiled to an execution plan based on the statistics for the data you initially supplied to it, and the data you're now querying or updating looks nothing like that due to the parameters that you've put in. So consider executing those store procedures with recompile or creating them with recompile. It'll add about 0.5 seconds to the overall execution time, but it means that your stored prop will dependably execute in a second or a second and a half or whatever it be, as opposed to every now and again going completely mad and taking ages. I think that's about it. Any questions from anyone? Yeah. No, again, it's a connection level setting. Yeah, so the transaction isolation levels, they're a connection level setting. The deadlock is also a connection level setting. Because the read commits a snapshot isolation that's a database level setting. So what I'm telling SQL Server, when I say set transaction, set deadlock priority low, is kill me before you kill a process that has normal deadlock priority or high deadlock priority. By default, SQL Server runs all processes in normal deadlock priority. In that instance, okay, so yeah, in that instance, it would depend how you're doing all of that. I think you could get into trouble if you were using the same connection pool for different things. Yes, because yeah. So you have the option of more than one connection pool? Right. Okay. So in your case, RCSI might be the better option. Come talk to me afterwards if you want to.
But basically, the level is the same. This low level that we should be first.
Yes, assuming you're not in contention with another process that's at a low level, in which case it will do the analysis that we normally do. Anyone else? Go for it.
You mentioned unit of work for handling deadlock issues in some cases.
Yeah, it's more for enforcing so it will handle the deadlock issues by enforcing disciplined order of object access.
Is there any alternatives other than service broker for that sort of pattern?
So with these guys, they've got a bit of a problem. So they're in. This is all in their C++ there. So I suspect they may end up rolling their own. So service broker is one option. There may be some other middleware providers that they give it to you out of the box, I would suspect. Anyone else?
The very first slide about the architecture, if you compile it, did you miss out on entity framework, or is that what I'm trying to do?
No, that's what client uses. No, it could have been. I think they could have just as well run into the problems they had with EF as with Hibernate. It's not a comment about Hibernate at all.
From the end of Windsor, you also need as well. What's the actual code?
So their unregistration code basically wasn't working for some. So yeah, for lifestyles exactly. No, they were created per request, but because they hadn't done their unregistration code properly, what was happening was that Windsor was continuing to track them after the request. So they should have been released, but that wasn't happening. So it's a really odd issue, and it shouldn't happen, and I've not we use AutoFactor. I'm working with the competitive market at the moment a lot, and we use AutoFactor, and I've never seen anything like that. And we use AutoFactor all dependency, so yeah, I suspect so. I mean, they've got a very large code base with about 60 or 70 projects in the solution. As I say, it's got they've got the classic London recruitment issue that they've had a lot of staff turnover. People have done things in a lot of quite different ways. So figuring it out and we were on quite tight time constraints at the time. So that's why I was like, well, just try this and see if it works. But remember, you've done this and go and fix it properly later. As I said, they're sort of working through fallout from that now.
You said the deadlock priority to low.
Yeah. It's so reading with no lock. Again, actually, that's an issue we discussed. No lock. So no lock is a bit like the kind of dirty read transaction isolation method. So it differs in that you won't read inconsistent data. What will happen is the process will get killed and you'll have to do the read again. So it's different in that sense. But yeah, they really won't happen if you like it run with no lock. And the problem with no lock is it's sort of it was something I suggested to you. I mean, if they wanted to do it, I would have said fine, but at that point, I don't think I think that was the first day I was there and we discussed that, and I didn't know enough about the domain to be comfortable saying this is the right thing to do. I think now that I know more about the systems, I'd probably be a bit more willing to recommend that. But because at the end of the day, you've got these devices that the moment somebody sings and then somebody else makes a change, well, that device has got data that's no longer valid anyway, so, you know, we know. say, it's not translations.
Lunch is served, everybody. Bear in mind it's got to do with